Today we're learning how to solve a systems of equation using the substitution method. Now, back in middle school, you learned how to do this using graphing. So when we're solving a system of equations, what we're doing is we're looking at two lines and we are finding out where they intersect, where they cross on a coordinate plane. And your answer is always going to be an ordered pair, that position where they cross. Like I said last year, you did this in graphing. So you would graph two lines on a set of graph paper and you would see where they cross. Well, that doesn't always work because sometimes we are dealing with fractions or decimals. They might not cross on a specific spot where you can visualize it. So we're going to be working this year on two methods of how to do this algebraically. That way, when you have answers that are fractions or decimals, you can be exactly correct, exactly where they're crossing and not have to guesstimate like you sometimes do if you graph. So we're going to be working on the substitution method. So here are the steps. Our first example is we're going to see where the lines y equals 2x plus 5 and the line 2x plus 3y equals 23. Now, in this case, we're going to be using substitution, where we're going to be taking part of one equation and putting it into the other equation. We're going to substitute y for y in one of the equations. And we use systems of equations with substitution when at least one of our equations is in slope-intercept form, y equals mx plus b, or at least we have one of those isolated. And generally, the other one can be in any form. In this case, it's standard form. Now, if they're both in y equals mx plus b form, that's even easier, and we're going to learn that with our next example. So our first step in order to solve this is we're going to solve one equation for a variable. So we're going to get x equals or y equals on one side. And at this point, you can already see that we do have that, y equals 2x plus 5. So in this case, step one is already done for us. So we want to make x equal to anything and y equal to anything. We want to isolate that variable on one side. So as you can see, we have y is equal to 2x plus 5. So the reason this is called substitution is we're going to take a look at the second equation and where we see our y, so we see 3y, we're going to replace our y with what y is equal to, which in this case is 2x plus 5. So we're going to rewrite that second equation, but instead of where we have that y, we're going to put in there instead 2x plus 5. So this is step number 2. Substitute what y is equal to or x is equal to into the other equation. So we're going to rewrite that. So now we have 2x plus 3 times the quantity 2x plus 5 is equal to 23. So all we did is if we cover this up and put y, we still have the same equation. We're just substituting in this green blob into where our y is. Now we're going to go ahead and distribute. So we have a 3 outside our set of parentheses. We're going to multiply that by each item on the inside. So we're going to have 3 times 2x, and we have 3 times positive 5. So as we rewrite that, we get 2x, 3 times 2x is plus 6x, 3 times positive 5 is positive 15, and that is equal to 23. Now we're going to go ahead and solve for our variable. In this case, it's x. Sometimes it'll be y. And we're going to go ahead and combine like terms on the left. 2x plus 6x is 8x. So we have 8x plus 15 equals 23. We're going to finish solving for x by subtracting 15 from both sides. 8x is equal to 8. We're going to go ahead and isolate by doing the opposite of multiplying by 8, which is dividing both sides by 8. So x is equal to 1. Now, we are not done with our problem here. Remember, our solution is an ordered pair where these two lines intercross. So we are now halfway through our problem. At this point, I like to set up my answer, which is a set of ordered pairs. And I know it's x comma y, so I'm going to put a 1 in my x position, which is the first spot in my set of parentheses. Step number 5 is we're going to take our answer that we got for x, and we're going to plug that back into an equation and solve for my other variable, which is y. You can get your answer regardless of which of the two original equations that you plug it into, but our top one already has y is equal to, and I'm solving for y, so that is the most efficient method. So here I have y equals 2x plus 5, and I'm going to replace my x for 1 and solve. So y is equal to 2 times 1 plus 5. Y is equal to 7. So I'm going to go ahead and take that 7 and I'm going to finish up by writing it as my ordered pair. And so I have the ordered pair 1, 7. And this is where those two lines intercrossed. Finally, we're going to check our answer. Now, there's multiple ways to check our answer. If we don't have a graphing calculator, we can plug X and Y in and make sure it makes both statements true. So for this top one, 7 is equal to 2 plus 5 when I plug those numbers in, and that's true. Here I have 2 times X, which is 2, plus 3 times 7, which is 21. And so we have 2 plus 21 is equal to 23. That's true. It has to make both of those equations true in order to be true. Now we can also check on Desmos, where we plug both the equations in there and click on that spot where they cross. And as you can see, these do interact at the ordered pair 1, 7. So those are two ways to check my answer. Let's go ahead and take a look at another type of substitution, which is called equal values. And this is just another way of substitution. It's actually a nice and easy way, but we use this when both lines are in slope-intercept form, y equals mx plus b. So our first step is write down y is equal to y. So here's our two equations we're going to look at. Y equals negative 3x minus 4 and y is equal to 6 plus 4. I write down y is equal to y. And I go ahead and take that first what y is equal to, which is negative 3x minus 5, and I put it on the left. And I take the second what y is equal to, 6x plus 4, and I put it on the right. So I simply put those equal to each other. At this point, I'm going to go ahead and solve for x. So I am going to add 3x to both sides, which leaves me negative 5 equals 9x plus 4. I'm then going to subtract 4 from both sides, which gives me negative 9 equals 9x. Divide both sides by 9, and I have x is equal to negative 1. Once again, I'm only halfway through. I'm going to go ahead and plug that into an ordered pair, set of parentheses with the negative 1 in the x position. My next step, I'm going to go ahead and take that x and I'm going to plug it into one of the two original equations. It doesn't matter which one, they're both already set up as y is equal to, and I'm solving for y. So pick whichever one you prefer. You're going to get the same answer either way. I picked y equals 6x plus 4 because I like dealing with those positive numbers. I'm going to plug in negative 1 for x and then go ahead and solve. Y is equal to negative 6 plus 4. Y is equal to negative 2. So I now have my ordered pair, negative 1, negative 2. And once again, I can plug that into the original equations to make sure they make both statements true. So I have negative 2 is equal to 3 minus 5. That is true. Here I have negative 2 is equal to negative 6 plus 4. That is also correct. Remember, they both have to be true. I can also check these on Desmos. So once again, ladies and gentlemen, we're going to get a lot of practice on our Desmos activity today. Once again, there's lots of places for errors, so you just need to take your time and make sure you're being careful with those calculations.